Yes, perfect. Yeah, thank you everyone for letting me speak today. I mean, for people who are not used to be with us in this call, this is earth science professional data professionals, let's say, how we call this organization? I don't know. Non-profit. The idea is just a way for people who are using Earth observation data. That's how I see it, and professionals of data that gather together and work together to improve our environment or improve the work environment or the work in general, collaboration. So I'm also the community fellow of the Open Science Cluster, and we thought that it would be cool to talk about the Earth observation and the open science and how they are. I will be just giving overview of how I see the thing, right? Um, so why it matters, why we're doing this, why we want to collaborate. And I believe that we are having the prism or the point of view that I'm looking for is from the climate change point of view and the natural resources point of view. And we have a common urgent issue that we're all dealing with, which is climate change. And we're having like an extreme climate events that is leading to we need to make decision better, and decisions that are made globally in all over the world may impact each other or may impact us. So we need to have a common approach to this decision making or collaborative way in how to do it. And one way is um, that we can see what is happening is using satellite data and Earth observation data. And we believe that doing it in an open way in will bring transformation and will create certain level of trust that we all need to take action. So what is Earth observation? So Earth observation is a continuous way to look at Earth from different lens and from different um, and to gather data about this biophysical um, system that we are living in. We have multiple missions, multiple satellites, and among them are Landsat, Sentinel, that are telling us or giving us um, recurrent information on biophysical data. So, but in the same time, this information is need to be open and we need to have access to it, and we have a continuity, and we need um, that everyone that can access to it and be able to use it, right? So we always talk about like there's like me trying to do this presentation was amazed actually on when I was trying to look at open science. And I realized that was also one of my motivation on joining the cluster is basically to learn more because it's confusing. So you have like the word open is used or everywhere, and we put open just to feel or seem that we are doing the right thing, right? And what really matters is basically the transparency, reproducibility, and accessibility and equity when we're doing science, basically. So we can talk about open data, and then many people stress that this is foundation of open science, and this is one of them, right? Many people have different definition, and we try to have a community like Earth observation community also that it's a paper that we are making in the cluster that how we see like open science from the Earth observation community. We can see also like the open one of the biggest, let's say in the science, one of the biggest like from my point of view, impactful way to science is the open access to journals, because this is a way that we can access to science and how people did their job, right? And we can work together and very beautiful, very nice, right? But the problem with this kind of with the open science that we're facing also is it does like it come with so much um data and so much exchange and so much like for example, in terms of data, NASA has made available more than 128 petabytes in the 2024, which is like crazy, and it's really increasing, but this come with a cost. The problem is recently we observed that all this in the US point of view, huh, the funding cuts that we that is happening is limiting, for example, one very basic thing, right? When you go to before, I was always directing people to the Open Science 101 in NASA website, and now we we cannot even do that, which is like very basic thing. But this reminds us that also the openness has a cost. Even if you want to publish in open access journal, this come also with a cost, which mean like doing things for the right thing, which is very like something that we're doing all together. We should also like remember that this has a cost, and we need to find a way uh, to do it like better, or to continue do the openness that we are talking about, right? Um, so one of the things that I would be focused in, and that was I was trying to do, basically, is in collaboration, but also in education and development of skills. I think that this is one of the biggest and most important aspect to do it, because it help actually raise the awareness that we all need each other and we should collaborate more, which is very interesting. But um, it does with it need effort, and this effort also need a cost. So what I have been able to pull up with my collaborators is this program that I will be talking about, which is the Open Climate Science curriculum for agriculture. The idea was, it started because like I'm doing my PhD in University of Maryland in geographical science, and my terrain of interest, or like my region of interest, in North Africa. And I was building collaboration, but the problem was I was having to talk with researchers and scientists that they didn't had the basics of Earth of observation, but also basics of open science. So even because of lack of funding and lack of opportunities, right? And also because there were other limitations, like the language barrier, the um, awareness barrier. The people didn't know that we have this much of resources around here, right? So we answered the call of TOPS. So that's where we had the financial support to develop this program, and we built this program around um, key skills that we thought that are very important are the computational data science skills. So we wanted to develop a group of people that can work with us, and we work all together in how to manage an Earth observation program, yeah, an Earth observation project, how to make it available to people, how to basically work together, and how you do it in the most efficient or effective way using your own computer, using like very low computational power. And this need a skill to reduce the amount of data we will use, and also to be able to, for example, take only the number, or the needed data, like only what you need. Not You don't have to download everything in your computer. So what we build the curriculum around the open climate data science, computational science skills, water, and then we had like three application: water resources, soil health, and crop condition and crop production. We have been able to develop fully the first three modules, because it need time, it need energy, and it need support, right? And that was the only, let's say, in a very vulgar way, I would say that was the only that what the money we received covered, right? We are now voluntarily developing the rest, but it just very frustrating, basically, to to try to do this effort that we believe in, but we cannot afford. Um, Beside the frustration, the program was super cool. How it looked like. Um, So what we did is we developed this GitHub Jupyter Notebook based programs that are done in English, and then we developed it in English, but then we translate it into French and Arabic for wider adoption. And we have been able to do some workshops. This is one of them that we have done in Algeria. And we had more than 24 attending in the CREAD, which is a Center of Research and Applied Economics. And we have been able to basically recruit new NASA Earth data users or make it a little bit like people were more aware that this data exists, but also we have been doing these workshops here in University of Maryland and in Montana University. So that's all I have. Thank you. And yeah, this is the website for people if they wanna have a look. And I wanted just to provoke the discussion of the Earth observation and the data science. Thank you.
Thanks, Walid, and thanks for sharing. Also, thanks for being honest about the frustrations of working on something that is open, but doesn't have enough funding for it. And I'll start the questions. If somebody, from outside, say for example, your consortium wants to contribute, how do they do so, and who do they contact?
Yeah, basically how we have been welcoming contribution is basically we put it everything in GitHub and we were receiving issues, for example, like, people would be like, there's an issue here, or we want to, we needed at certain point a lot of help in the translation and verification because I can speak the three languages, but I'm not, um, how to say, I'm not specialized on interpreting and translating. Sometimes some scientific words needed verification of people, and like a community deciding that that's basically what granule, for example, climatic granule means in um, how to say means in French or in English, because granule in French doesn't mean the same in English. So it's super interesting. And then the second type of way that we were receiving help, it was basically people reaching out to me or to Arthur, and we have like a one-to-one help. Like usually people who want to volunteer are they have a specific thing that they can volunteer. But also this was also challenging because we have a limited amount of time, right? Like it's very cool to welcome people, but it's also hard to manage it. Like it at certain point I was like feeling so guilty because many people were reaching out, but I was not able to follow up, right? It's yeah. I don't know if I answered your question.
Yeah, no, for sure. And if you don't mind, if you can flash
Yeah.
the QR
Oh,
code
sure.
and the website
Sure,
again
sure. Sorry, I stopped sharing.
for folks
Um,
who are interested.
yes.
Hey Walid, how's it been going with engagement with your TOPS project since it ended? Is it
Uh,
zero?
yeah,
Do you still have people working on it?
yeah. The thing is, we are still working on it in a voluntary base, right?
Right, right.
We have some actually some companies and that they took over the program and offering it through their like curriculum of capacity building in for their clients. That was super cool actually to see. It was frustrating to not be able to follow up with them, right?
Right.
Because we have other things to do in life. Like I'm
Yeah.
in the end like of my PhD also. It's also a little bit stressing. But yeah, it's super cool to see that there is people taking it over and developing it and making it more um like twisted a little bit for their needs. So I don't know if
Hmm.
this is the what you want
Yeah,
me
that's
to
what I was
answer.
asking.
Oh,
I've had success. I've had success. I'm leveraging the platform we set up, and I'll talk about it in a minute. Um,
cool.
by just including in different proposals stating that we're going to put our support materials on this platform, and it's got NASA branding, and we've had success being able to just piggyback some money here and there to create curriculum to add to ours. So I talk about that when I do mine, but
Oh, that's so cool.
another avenue, because it's frustrating that everything just kind of blew up and dropped off here, but whatever.
Yeah, I think in our case it's just the ability to follow up basically
Yeah.
and like keep up with the demand. We had like so much demand into going doing workshops, for example, overseas because of the translation. You know, the that gave so much actually accessible opened so much accessibility to people to be like going. I mean we have had like the people who took over ran the like without us they ran the workshop in Mauritania and in Congo and uh and in Tunisia, I guess. Yes. So yeah, that's good to see. But you know, it's that's the goal actually.
Very good, Walid. I enjoyed it quite a bit. And we should talk also afterward because at Ezra, we have a whole education team who also puts forward learn courses for end users and pay a fee for authors of course content and bring a whole team to assist because, as you say, it is very difficult to follow up and it's a lot of work when you have many folks coming, but we've got quite a bit of success in doing that. And for example, right now going on, just started last week, is it Imagery MOOC? I'm pretty sure most folks here on this call know about MOOCs, massive open online courses. And we work with a lot of folks to make those available for end users. And one of which that we do is on climate science. And so maybe that some component of what you presented can be incorporated into that as well. And I know we did the climate action, I think is what we called it. The last one was last year, and we had 32,000 folks attend the course.
Wow.
Yeah.
There is definitely a huge interest, huh? It's recently have done an online workshop on the satellite enabled agriculture use, and I was unexpectedly surprised. I had more than 500 people registering in like it, and it was only no certification, just people I put together some people from, I mean, that I know and researchers that are super, I mean, they're brilliant, but I wasn't expecting to have like that much of interest. So the interest is there. There's so much interest and there's so much, and people attended. I mean, it was so cool. So yeah,
Very good.
good, good. Um,
Okay, do we have any more questions or should we move on?
There are no other questions. I think we can move on to Josh's presentation.
Mhm.
Walid.
yep, I stopped saying. Thank you.
There we go. I posted a chat a link in the chat. So these are all live on Git. So if you're interested in any of these projects and such, all the links should work, and you can follow along or check it out later at your own time. So my name is Josh Brinks. I'm a research scientist with ISciences LLC. We're a small private firm located out of Burlington and sometimes Ann Arbor. I live in West Michigan, moved back from Burlington recently. And I'm just gonna go through quite a few open science projects that we are part of, even though we're a private firm. So kind of get the word out on some of this stuff, and also just kind of show what it looks like for a private research firm to kind of operate in a very kind of federal / academic open way as much as possible. So like I said, I'm just going to hit one slide on kind of us, and then I'm going to run through a couple slides each, or maybe one slide each, on a bunch of open science projects we work on, and then I'll just wrap up with a few closing thoughts. So it's not going to be very high level open science discussion that Walid started off with, but a little more nuts and bolts. So good compliment. So who are we? We're at FOSS. I like to describe ourselves, and I don't spend a lot of time on this because I'm going to be highlighting the FOSS components of our firm, but lots of times I'm giving other types of talks. So we're a FOSS focused, I like to call us, research firm out of Burlington. We specialize in geospatial analytics and applied statistical modeling. We mainly focus on water resources, drought, floods, political instability, environmental monitoring, risk assessment, et cetera. We're a small team of scientists, engineers, and developers, and probably could remove the S from all of those where it's scientist, engineer, and developer. So there's no more than 8 to 15 of us at any given time in the 8 or 10 years I've been. And so what do? We partner a lot with agencies like NASA, NOAA, United States Army Corps of Engineers, specifically the hydrology labs there. And but we also do some intelligence subcontracting through your big players like NGA, Maxar, Lato, stuff like that. We develop our primary product that is open, that I'll talk about later, is the water security index monitor and water security indicator model, sorry, WSIM. But we also, as you'll see, develop a lot of open source softwares and packages. I forgot to reset my timer. And lots of open science software packages and educational materials that I'm going to talk about today. We don't need to work on this. This is your classic Open Science 101 NASA circle. And I think most of us by now hopefully are aware of the broader benefits of open science and why we practice it even as a private firm. It helps us internally reduce barriers and learn and train our people. It helps us maintain our products with our clients because we don't have to worry about licenses and all this types of stuff. And you can get the word out there and get support and build a better community with transparency, even if you have a private client. So the first project I'm going to talk about is Dante. This was a collaborative open science. Most of these on the bottom here, you can see that we have links. So these should all be active if you're checking out stuff online and see the GitLab project is still working strong. Some of these links, they don't like inside of Slide.io, but if you just copy the link, it actually does work. So anyways, this was a collaborative open science coming out of a SCTR grant, which is a type of federal grant if you have a partner. In this case, our partner was the Coastal Hydrology Lab at the United States Army Corps of Engineers down in, I think they're in Mississippi, I don't remember. But we also were working with one of our primary partners that we work with pretty much exclusively on a lot of open science stuff, Columbia Season Institute. And then we also had another private firm that was doing some outreach for us, who was basically an ex-NOAA employee. This was a pretty focused effort of developing curriculum, R packages, maybe a little Python stuff, and vignettes and kind of educational materials that was supposed to be at the intersection, what they call climate security. Climate security is where political science, social science, geography, migration, environmental kind of all come together. And lots of times it's leveraged in defense communities. In this case, our government partner, the Army Corps of Engineers, they do lots of support for floods and disasters around the globe. So we work with them a lot, providing some of our expertise and developing training materials for them to use. This was a very well-funded, looking great project. And then our outreach and stakeholder phase coincided with COVID. So everything kind of blew up and smashed into nothing because all of the conferences and such and workshops were either canceled or converted to virtual, which often at that time at least weren't very great. So this has kind of been defunct for about 3.5, 4 years, but it did kind of merge into our next project that I'll talk about. This is called Top School. This is our joint effort, continuing with Season from our previous work in Dante. This is Top School Science Core Heuristics for Open Science Outcomes and Learning. Our partners at Season love a good acronym, but we were a Science Core team, much like Walid's. So we don't need to talk too much about basically what it is, but we worked with Season and a couple professors from CUNY. and we were emphasizing curriculum development for hands-on learning with NASA data sets, but also a lot of NOAA data sets, NCI, and other public USCA. There's a large variety of stuff. We developed 4 modules each with between 3 to 5 lessons. So you can see the bottom here, we have our water module, our air quality module, disasters, and then climate ag. Each module is all built up on GitHub and has landing pages. And then you can get into the deeper lessons. We, much like Walid, successfully ran all sorts of virtual and in-person workshops, generally partnered with 2I2C for our virtual computing platform, so we could give them our Docker image that was all ready to go with all the stuff people needed. And we would work through a lot of our lessons, which were all focused kind of on case studies. So we would, I did some examining the Canadian wildfires of 2023 and the Yellowknife evacuation. I did a lot with looking at air quality in Detroit Metro. I did a special, or not a special, I did a lesson looking at how to examine the 2022 Southern Plains flash drought using a variety of NASA and NCI and public federal open data. These lessons are pretty long. Click one of these up here. So similar to Walid, we have lots of knowledge breaks, call outs, well-cited introductions, drought in the news, and we go through in very detail on how to acquire, 4 or 5 different data sets, get them all prepped, acquire them programmatically, what packages you need, how to do it, how to integrate them, and then come up with kind of a simple analysis. We kind of usually stopped at before you would go into a proper modeling. But in many cases, this is really the complicated stuff, is how do I get onto Earth data with R and use my environmental file and get all the data in, and how do I match up Sportless and GOES and all these different various remote Earth science data sets and integrate them with maybe local municipal boundaries and population data. And so we go through in quite detail on how to do all this stuff across, like I said, we've got about 15 to 20 different lessons looking at a variety of things across those modules I talked about: air quality, environmental justice, et cetera. So it was a broad research effort or curriculum development effort that was doing pretty well. And like I said, we're still using it to piggyback, for our open science data management plans. When we submit grants, we always talk about putting our curriculum in here, and this is the place. And at least it's not, you're not saying I'm just going to stick it in Git. I can say, this is our NASA TOPS open platform. We're going to use this. We can develop it. We have a couple of capstone classes that we've integrated with. They're not necessarily all that interested in the domain, but they are interested in the backend programming aspects. So we do have a fair amount of involvement with students working out of National Louis University in Chicago. This is our main one. And they get students every trimester, and they're building Sphinx websites for us and going through and flourishing out a lot of the lessons, creating lessons of their own. But like Walid said, you can get a lot of involvement and it can become overwhelming. But we found that, and sometimes they want to do stuff that maybe is not even all that helpful in terms of our mission, but you can only get people to do what they're interested in. So if some kid wants to build a whole version of this website that's in Sphinx because it adds a little value add, then great, we're going to help them through it and let them get after it. So this obviously just ended with TOPS in June. We did put in a very well-reviewed extension to talk about the need for developing AI literacy called Scalar in Earth science workflows. So we've been, at various ESIP meetings, AGU stuff, we talk to a lot of people, and there seems to be a lot of people who don't quite know how to leverage your out-of-the-box AI to help you blast through a lot of these difficult things, developing R or Python APIs, having them help you access data, having you help them integrate data, and they're very good, many of the LLMs like Claude and ChatGPT and stuff, at working in these spaces, because in most cases it's fairly well documented, or you can just give them the API documentation and they will build the functions for you. But helping you also look out for a lot of the issues like hallucinations and bias and validating AI code and such. So we have this out here hoping to get it funded somewhere, but all the HPOS funding kind of went down the toilet this July or with the political transition. So that's something we're looking to continue our science core on. Next thing I'm going to talk about is our NCLIM Grid Explorer. This was actually funded through an ISciences lab grant last year on the 2024-2025 cycle. This is something I mocked up looking at the NCEI's NCLIM Grid data set. So that's a daily rasterized data set going back to 1951, showing maximum, minimum, average temp, and precip in the Con USA. And like a lot of our open source tools and stuff that I'm talking about here, this is just stuff that I was kind of mocking up in the office so that we could easily look at live NCI data coming straight off their AWS bucket. So this accesses, let me show you right over here. It's a basically Shiny app that I propped up. We can still see this, yeah?
Yep.
Okay, cool. So this is live. This is running AWS. It allows you to pick any date in this NCLIM Grid daily data set from NCI going back to the 1951. And you can pull up any of the live view or switch through any of the different variables that they offer. I've limited it here on the viewer because census tracks can kind of bog it down, but we've got about 100,000 different boundaries that you can use, and you can go live here and just run a zonal extraction in any of these if you want to find out. This is where I am, so I just take this one, but it'll do a live zonal extraction and show you mins, means, maxes, etc. It talks to the live data set on NOAA's or NCI's NOAA AWS S3 bucket. This is where this data lives. But you can also, I've also ran backfills for all these 100,000 boundaries. So we have, HUC6 watersheds, counties, metropolitan statistical areas from the census data set. So we have a variety of boundary layers, and then I've backfilled the daily averages of all 4 variables going back to 1951, and those sit in a S3 bucket, a cloud bucket that I made, and you can generate, various forms of data sets of these variables and download it if you want to not only kind of just use the viewer to look at what's going on daily, you can also, I didn't pick one. You can also build a custom data set and download it that takes these zonal extractions that I've backlogged and filled this S3 bucket with. So everything here is kind of live and on the move. Sometimes it's a little slow, but I did cheat and go into AWS today and boost up all the settings so that it should go a little faster. But depending on what you're trying to pull, it's billions and billions of records here. But you can create custom data sets of your region of interest and look at daily climate variables, see some highlights. You can also go in to a more complex and do some climatology analysis. So here we've got, I just picked Alabama because it's the first thing, but it'll perform climate circle visualization showing you climate for a given day in your area going back to 1951. So if you're interested in kind of what's going on a per day basis. And it does structural decomp for long-term climatologies. You can do threshold analyses where you pick the number of days in a year that either go above or below a certain threshold for a variable of interest, etc. So a lot of cool stuff to check out different aspects of climatology in areas of your interest. And, a lot of stakeholder possibilities here. I'm looking to move forward with the next round of funding on this. Hopefully, I just finished up work on it through my ISciences money, but it's kind of beta, but it's out there and you can access it. The link is shown in the slide deck. It's nclimgrid.isciences.com, so it's also in there. Next I'm going to talk about real quickly here, I'm at about 12, 13 minutes. We've got our exact extract package. This is something that my partner does. This is the best, the fastest, the most amazing zonal extraction tool you can get. Nothing's more precise and nothing's faster. It is fully open. It currently it started as a Java command line tool, but it has an R package. It has a Python package. It's, as I'll talk briefly, it's going to be integrated in the most recent release of GDAL. It's mostly been supported through NASA ROSA grants, just similar to TOPS. This is awesome. If you don't know about this, it beats any tool you're using. So if you are interested in zonal extractions, and if you don't even know that much about zonal extractions, like say, how does a cell get assigned to a vector polygon? You know, so you're overlaying, say, cities, counties, boundaries on top of a grid, and you're trying to summarize those boundaries. You can get orders of magnitude difference in values depending on how those algorithms work. Many times it's, do you just barely cross the cell, then you get all the value, or do you cross the centroid, you get all the value. So there's different rules, and I didn't even realize this was born out of me getting really upset sitting next to Dan, and he was like, "What are you complaining about?" And then I started to explain my problem using various Esri and QJS and VLOX and such, and he said, "Oh." So we got into looking at how these algorithms work, and it's been widely adopted and it's a great tool. So if you ever do zonal extractions, I recommend you checking it out. Like I said, this technology or this code is being integrated into the most recent release of GDAL. We are GDAL contributors. We compete and support a lot of FOSS code hacks, hackathons, and you know, this is mostly Dan Bastion, our engineer, but we, along with him, we're kind of, even though a private company, you know, we're fanatics for open science and open tools. So we contribute to all these areas when possible. So if you're not, the newest GDAL's got a bunch of great stuff coming on it, and it's, if you're not aware of it, it's pretty much the backbone of all geospatial analysis in, you know, pretty much any package you would use. It, R, Python, etc. At the lowest level, they're just talking to GDAL in the background. So we try to contribute to GDAL and give it enhancements that we could use most. I mentioned this earlier, another project, this is our longest running open source project, is the Water Security Indicator Model. It's a global forecasting tool, does seasonal to sub-seasonal 9-month out lead time forecast. It also has observed data going back to, you know, whatever possible, 1951, 1980, it depends on the inputs that we're using in the current version. It's fully open source code base. The link's here in the bottom. You can run it on your own. It's been developed mostly as a feature for hire kind of thing, where we help companies, the Marine Corps, or who knows, whoever wants to know about water anomalies, we help them get it set up and running and add any features we want through funding that they want, I mean, and then keep it open. And, you know, hopefully we're trying to find a grant to move it fully into the cloud. You end up with, this is the most recent United States seasonal forecast. So you've got the first through September 2025 observed, and the next 3 months blocks heading out into June of next year. So this is kind of data it produces, and we don't issue the data in the cloud or anything, but we do produce regional monthly blog posts that detail what the conditions and the forecast in about 12 areas across the globe, showing anomalies where you're either going to get, you know, high expected relative stress anomalies in dark red, floods, dark blue, or you're going to have both, which will be pink and purple. So getting long on time here, I think that's about it. And then lastly, we have multiple employees who serve at drought.gov and various open capacities there, and developing mainly the drought.gov website. And then similarly, we have hopefully a new grant coming through NIDIS, if Mr. Lutnick will sign off on it, dealing with non-stationarity and climatology, long-term climatologies. So we're hoping to have a full open science project here if the money gets issued out, with stakeholder advisory panels, you know, all sorts of cloud hosted open data and code for doing long-term climatology analysis on non-stationary data, and integrating it into the drought.gov forecasting and warning system. And we're going to do a little preview of this at AMS in January, but we're still dealing with the political machinations there. So kind of hit on a few of these here and there, but, you know, for the most part, we have at times we struggle with engagement and stakeholders with some of these projects. Often I think it's just because it's been a niche domain, like with our Dante climate security work. But if we stick to a broader kind of earth science type area, we've had success in generating community. So we try to keep it open. We try to simplify our front end products. So the platform is important. If you don't have a place to put these, that's not just like a repo without a front facing website, it can be difficult. It's good to piggyback onto greater efforts when possible. And, you know, not everyone is still on board yet with some open science. So mainly our corporate customers, but you still can run into issues here and there. And so just be aware that everybody's always as fanatical about it as you are. So that is all I got. Lots of people to thank: ESIP, NASA TOPS, all the people I've already talked about, Columbia, and various FOSS and open source partners that we've had over the years. So thank you.
Thanks, Josh, and thanks for sharing the lessons learned. I think also some of those touches on um, part of Walid's presentation.
Yeah.
Yeah. I have a question for you in terms of all of these tools that you put out. Are you able to monitor and evaluate the users and the number of users, for example, or what their feedback was on all of these tools?
And sometimes we do. Lots of times, frankly, a lot of them just sit in the ether, and I'm okay with that. It happens, it's just they get released. There's not maybe a big user base, or we don't have a specific metrics a lot of time. I don't think any of our tops, we haven't set up all the Google Analytics for our large tops program. We've had lots of interest, like Walid, with our workshops and such, and our kind of capstone class engagement. So we don't always know necessarily, it's just kind of a feeling. And lots of times we just operate where I'm working on something, even if it's for a private company, but the code and the data can be abstracted from whatever's shouldn't be opened up. And we just will make sure we release it so someone else might want it. And occasionally that leads to something bigger, like our huge WSIM product where we have giant mailing lists, and we have a lot of interest there, and it gets continually funded, or exact extract, or sometimes it's hyper narrow curriculum about international security and climate, and it probably maybe 10 people have read it. I don't know, but if anything, a lot of these things, when I work, I always try to post stuff and just put it up, even for myself in 5 years, because someone might be like, can we do this again? Or I might say, oh, I had that thing. And if I took the extra day to just write a nice little lesson about it and put it online, then it's always going to be there for me at the minimum. So.
Thanks. Any other question for Josh?
Oh, I'm
Laura,
unmuted. Can you hear me? Okay, thanks.
yes.
So I really liked when you went into, you had those use cases and you went into the extensive documentation. I believe they were for either the project or potentially courses that were delivered to. Is that correct? Like, were they courses that were delivered to for somebody else to do a similar project, or?
No, we just developed curriculum for the ether. I mean, NASA was funding a lot of that type of stuff. The platform, I think it was meant to be integrated into a lot of their internal trainings.
Mhm.
So NASA was also hosting trainings internally, and then they were sponsoring people like us and Wiley to hold workshops. And I think eventually they want to integrate everybody's individual Git platform into a large curriculum learning resource that could be integrated into graduate seminars, or because some of ours are pretty complex, or just you can see that there's a lot of applications for learning and
Right, yeah.
hands-on stuff there. So that's kind of how it was, but everything is kind of fallen apart. So we're deciding how to pick up the pieces and move forward.
Okay, so those the project work, all that document, is that on GitHub or that's still
It's all on
internal?
GitHub. You can check these this presentation that's in the chat links. You can go right to this presentation, go to that slide. You can click on all the modules. You can click on all the curriculums. You can see
Okay.
they're all in there. There's about 20 lessons, each that are about 2.5 hours length.
Mhm.
And they walk through those types of earth and social science problems.
Yeah, okay. No, I find that very interesting. Just because yes, I am with a privately held company, but we also have a large field of open science, and we cater to our users in many different ways. One of which is trainings,
Yeah.
learning online modules, and they're all complimentary. Nobody has to have the software that some of them is really extreme. All actually none of our own software, but open and working with R and Python and things like
Yeah,
that.
sorry, there's no Esri lessons and all that stuff, but yeah, I see
No,
what you're saying.
I'm not saying that. I'm just trying to give you an insight into, even though we're a corporate, I mean, a private company that has our own software, we still also have a very large open science space as well. and topics that you talked about and presented would be things that, we work with other leaders as well, and actually put out a learning course for users to gain access, and it's complimentary. And we have it's a mothership, so there's a large infrastructure behind that to ensure that that is made available and usable by many users.
Yeah, well, at this point, that's one of the primary ways a lot of our open science people want to pay you to write the long form vignettes, but they don't necessarily have the platform or haven't gotten in touch with the right people to get it in front of eyeballs that will be useful. And so it's very decentralized and sparse, even though it is free and open on Git. You have to stumble upon it, et cetera. So, they need to improve get in contact with people like you and others who can get that in front of the right audience.
Yeah, well, yeah, I mean, we have there's a lot of users.
Yes,
So
find the users, because it seems like they would exist, but you've got your graduate seminars and such, and unless your professor running that seminar was part of one of these top teams, they're probably not going to take the time to try to integrate your work, even though it's possibly more relatable and hands-on and applicable to their students than anything they're working through in their textbook. So that's one of the more logical, in addition to the professional development, that those platforms. So it's just difficult getting it in the right place where it can be used. So it's not just me, my personal notebook.
Right. Yeah, exactly. No, I see that struggle a lot, and work with a lot of universities where, I mean, they just find it hard to even, like professors, to even take on some new content and input it in for, the next semester or what have you.
Yep.
And yeah, trying to find ways to help them be successful. It's no easy task, but it's definitely something that has to keep continuing to try to move forward. Just as you said, when you finish a project or whatever, you want to write up enough documentation and publish it on GitHub or something like that, so that maybe 5 years from now you could go and see. I think that's still very important, so that others can start to come together. Yeah. Do we have any other questions? Go ahead, Bruce.
Yeah, this is just a note that the getting a graduate degree now in data science is something that's fairly new, but I think it's spreading around. I know Texas has it, UCSB has it. I don't know if there's a consortium of schools that are doing data science graduate degrees, but I think that would be a good customer for your work.
That's where we've had the most success with engagement at the university level. It's been computer science capstone in seminars. So I think often the technical coding capacity component of some of these lessons go beyond undergraduates. And I don't think they should have to, but it might be seen as a bit too much. And so lots of times computer science kids latch onto it, even though they don't give two about water security or migration. They just like the tech back end and like a playground.
Right.
Also,
Yeah, the
really
Bren School
helps.
here, I think would eat this stuff up pretty well.
Yeah, I was saying, I think it also really helps that you kind of just have it out there. And I'll share an anecdote. At OpenAQ, we get approached by master students who are doing their capstone projects. And they find OpenAQ, this open air quality data set, and they're like, we want to, do some algorithms and say, for example, this one project was looking at how do we better place sensors in different areas, and how do we evaluate the stability of an air sensor network. And so because this open data set just kind of exists out there, they were able to use this data for their capstone project. So I think just having all of these out there, someone is bound to find it and
Yeah, we have an air
able
quality.
to
We have 4 air quality lessons showing how to get ISIS air data, toxic release inventory, federal data, plotting it all out, all that kind of stuff. So using sensors, all that kind of, we have one that put sensors in elementary school throughout in New York City and followed that and showed you how to map it out. So yeah, lots of stuff.
This is Carla. I'm just going to throw in a plug for the K-12 space again. I know you guys are saying this is complicated, but there are bits and pieces that definitely trickle down. And Arizona is still actually doing a ArcGIS. Well, it's not ArcGIS, but they're doing the competition that Esri used to do for years. Um, the I guess it's called middle and high school. I think they actually extended it to K-12, the whole K-12 curriculum. But it's a competition where kids have to do a project. And then in the past, ESRI would recognize their projects. But it's absolutely amazing what some of these middle and high school students can do with open access data. And in particular, we've been focused on the GIS data, but it doesn't, for the K-12 space, I'm just really pleased by all these modules and things. So, and if you don't know me, I'm the chair of the education committee, which is very small at this point. We lost an awful lot of folks from NOAA and NASA and whatever that are no longer allowed to participate. So.
Questions or comments for Walid and Josh?
Well, I'll just say, I think it was very interesting to see two different takes on project work and whatnot, and some lessons learned, and then the honesty of both presentations. And I really appreciate that because, yeah, sometimes doing the right thing is not easy, I kind of say, and I think being open and accessible is the right thing. But yeah, it's not always fashionable. But I see great opportunities, just even from both of these talks. While it's the amount of folks that were able to be reached and different languages, making that accessible was awesome. And then all the different projects that Josh talked, that they varied quite a bit. And so also, demonstrating different capabilities across a spectrum of disciplines is also quite important. So I enjoyed them very much so.